Today I'm taking a look at a desktop CNC mill that aims to be almost as approachable as a 3D printer. It comes with automatic tool changes, built-in dust collection, and even a laser module. We'll start with a simple first cut, then make 2 aluminum fixtures, and finally machine a complete brass watch dial, including a guilloche surface pattern. At the time I'm recording this, Makera offers 2 CNC mills, the Carvera and the Carvera Air. They've also just opened pre-orders for the Z1. All 3 machines differ in features, weight and price. I went with the biggest and heaviest model because extra mass usually means more rigidity and less vibration while cutting. Makera sent me this machine for testing, but this video wasn't influenced by them in any way. As always, you're getting my own honest impressions. The Carvera is a fully enclosed desktop CNC designed for precision prototyping and small-scale production. It includes a 6-tool automatic tool changer, a wireless touch probe, and an integrated dust collection system. There's also a 2.5 watt laser module on board for light engraving and marking, and it supports an optional 4th axis with a harmonic drive for rotary work. The spindle tops out at 15,000 RPM and puts out around 200 watts of power, which is plenty for wood, plastics, aluminum, and even brass, as long as you use conservative feeds and speeds. Motion is handled by ball screws and linear rails on all axes, driven by closed-loop servos for accuracy and repeatability. The working area is roughly 360 by 240 by 140 millimeters, which is more than enough for fixtures, watch parts, jewelry, and most small parts. The standard collet size is 3.175 millimeters, but 4, 6, and 6.35 mm collets are available from Makera, and swapping them only takes a moment. The workflow is pretty straightforward. Set up your job in the CAM software, assign your tools for the auto changer, post the G-code and send it to the machine over Wi-Fi or USB. All G-code files are stored locally on the machine, so even if the connection drops, the job keeps running. We'll start simple by cutting a plywood wasteboard that will protect the MDF bed underneath. The machine first picks up the Z-probe and checks its height. When scan margin is enabled, the probe outlines the area where the next toolpath is going to run. That gives you a visual reference, so you can make sure nothing is sticking into the work area. Now, the probe is measuring the actual stock height. Once the probe is released, the spindle automatically grabs the end mill for the cutting operation. For this job, I'm using a 3.175 mm flat end mill designed for wood. Next, the Carvera measures the tool length, and the cutting operation starts. When I filmed this, these spoilboards weren't available yet. Today, you can buy them pre-cut and ready to use directly from Makera. This wasteboard will protect the MDF base whenever a cut goes all the way through the material. Next, we're going to machine some aluminum. These aluminum sheets are also available from Makera and are made from 6061 aluminum. I'm machining a fixture to position my warranty cards accurately for fiber laser engraving. I'm enabling auto leveling with a 3x3 grid. After running the scan margin, the probe measures 9 points inside the work area. That compensates for small variations in surface height, which is especially helpful when you're working with tight tolerances. The outer pockets are cut in a single 3 mm pass using an adaptive toolpath. And the built-in vacuum does a great job pulling away all the chips. The inner pocket is machined in 2 stages, a roughing pass at 0.7 mm depth, followed by a finishing pass at 0.1 mm. That looks nice, let's see if it works. I'm using my fiber laser to engrave the fixture itself. This jig makes sure every card sits in exactly the same position, so the laser engraving is always consistent and perfectly aligned. That fits perfectly. The Carvera also has a 2.5 watt diode laser built in, but since I already have a 60 watt fiber and a 40 watt diode laser in the workshop, I haven't really used it yet. At 2.5 watts, the diode laser is a bit underpowered. I'd see the built-in diode more as a convenient add-on for light engraving on softer materials. The dust collector also worked really well. To show more of the cutting action, I'm going to remove the dust shoe for the next part. If you hook up a compressor, the Carvera can also use air blast for cooling and chip evacuation. That's a nice feature, but because I'm filming with the lid open, I'm not using it here, otherwise the whole workshop would be covered in chips. So let's watch the Carvera in action again, this time without the dust shoe. The automatic tool changer now picks up a chamfering bit. Once again, the result is very precise, with almost no visible play in the fit. Now we're going to machine a two-piece brass watch dial. We start with a small engraving bit, then run 3 drilling operations, and finish with a contour cut. Tabs are added, otherwise the dial could come loose during the final pass. For the lower dial layer, I'm starting with a 3 mm thick brass plate. I've already machined the underside to bring it down to the final thickness I want. The program begins with a 0.1 mm by 30 degree engraving bit. You can both see and hear that there's quite a bit of vibration, mainly because I machined the underside first, and the remaining material is now only about 0.5 mm thick. I'm now cutting the dial out of the plate by hand. I just need to remove the remaining tabs. Now let's add some color to our dial. We need a degreasing solution, distilled water for rinsing, an activator to help the plating bond strongly to the brass, and a smoky nickel plating solution. I am using a stainless steel electrode at 6 volts to degrease the part. Rinse it off. Then I activate the brass using a stainless steel electrode at 3 volts. And finally, I nickel plate the brass with the smoky nickel solution using a platinum electrode. That already looks pretty cool. Now let's prepare another brass plate for the upper dial section. First, I'm electroplating it with a gold flash electrolyte using a platinum electrode at 3 volts. This gold flash creates a barrier layer between the brass and the rose gold plating that follows, so copper from the brass doesn't diffuse into the rose gold over time. Now I apply the rose gold plating, again with a platinum electrode at 4 volts. I noticed a bit late that the surface still has some scratches, but since this is just a test piece, I was okay with that. The Carvera is auto-leveling the surface. And again, I'm using the engraving bit to cut the lettering. After that, I added chamfer to the inner and outer edges of the chapter ring. The last machining step is contouring the chapter ring. You can clearly hear how much the brass is vibrating here, because I removed most of the material on the underside first. That's definitely something I'll change on the next project. Now that we've machined both parts, I'm taking some measurements. The dial feet are designed to be 0.75 mm in diameter, and I'm impressed by how accurately the Carvera hit that dimension. The final question is, do the parts fit together? And yes, they fit together perfectly. I really like how this watch turned out, and I'm excited to see what other dial designs I'll be able to create with the Carvera. As I mentioned earlier, it really wasn't a great idea to thin the brass plate down to its final thickness before doing the engraving. With the material reduced so much, it started to vibrate heavily during the engraving passes. So I ran a small test series. I'm taking another 3 mm brass plate, but this time I'm engraving the top side first, while the material is still thick and stable. I'm comparing an uncoated 90° chamfering bit with a zirconium nitride coated 90° chamfering bit, running them at different feeds and speeds to see which combination performs best. As you can see in the bottom left, even at the full 3 mm material thickness, there are still fine vibrations visible in the bottom of the engraving. In the top left, we see the same tool path but with the coated cutter. The result is slightly worse. The coating does increase tool life, but it also softens the cutting edges a bit, so the engraving isn't quite as crisp. In the top right, I'm back to the uncoated bit and running a lower feed rate, and you can already see a noticeable improvement. And in the bottom right, the setup is the same, but I added a 0.05 mm finishing pass, and that produces a very clean, sharp engraving with no visible vibrations at all. All of these tests were done with a clearing pass, basically a second pass at the same depth, to compensate for tool deflection. The chamfering bit I've used is 50 mm long. With a shorter tool, which naturally has less deflection, you'd probably get even cleaner results right away. Finally, let's take a look at the 4th axis module. This add-on lets the Carvera handle rotary machining. It's not something every user needs, but for the right projects, it opens up a completely different set of possibilities. The working area of the 4th axis is about 9.2 cm in diameter and up to 24 cm in length, which is plenty of room for small rotary projects. It's powered by a NEMA 17-stepper motor and uses a harmonic drive system, so you get smooth motion with virtually no backlash. After spending some time with the Carvera, I'm honestly impressed by how much capability Makera managed to fit into a desktop machine. The automatic tool changer, the probing routines and the built-in dust collection make the entire workflow feel surprisingly smooth and approachable. And for anyone who needs it, the integrated diode laser and the optional 4th axis module add even more flexibility for specialty work. I also want to point out that I'm a complete beginner when it comes to CNC machining. Before receiving this machine, I had never operated a CNC mill or generated a single line of G-code. The fact that I was able to go from zero experience to machining a brass watch dial in just a few days says a lot about how accessible the workflow really is. Sure, it's not meant to plow through metal like an industrial mill, and you do have to respect the limits of a small spindle. But as long as you stay within those limits, the results are remarkably precise. Overall, the Carvera strikes a really nice balance between ease of use and high accuracy machining. And with 3 different machines in Makera's lineup, there's essentially an option for every budget and every level of ambition. For me personally, it's a great tool that opens up a whole new range of ideas.